Hi, and welcome to day 2 of sequences in series. Today we're going to be talking about recursive definitions, and the objective is to find sequences defined recursively to solve problems. A recursive definition is basically means that we're going to use the term prior to find the terms after it. So sometimes a sequence is defined by giving the value of t sub n in terms of a preceding term, t sub n minus 1. For example, consider the sequence defined by the following formulas. If t sub 1, my first term, is 3, and t sub n is 2 times t sub n minus 1 plus 1, the second formula above states that the nth term is 1 more than twice the n minus 1 term, n minus first term. Knowing that the sequence begins with 3, we can determine the first two terms of the sequence as follows. So all I'm going to do is put in t sub 1 here, and I'm going to say to find the second term, which is here, that's the second term, I need to do 2 times the first term plus 1. So 2 times 3 plus 1 is 7. To find the third term, I have to take the second term, multiply it by 2, and add 1. So 2 times that's 7, plus 1 is 15. To find the fourth term, I use the 2 times the third term plus 1. So that's my 15. So 2 times 15 is 30 plus 1 is 31. So every time you are finding the term, you have to use the one prior to it. Now, with what we were doing yesterday, you had a formula and you could find any term, and they didn't have to be sequential. The formula is t sub 1 equals 3 and t sub n equals 2 times t sub n minus 1 plus 1. Give a recursive definition for the sequence 3, 7, 15, 31. A recursive definition consists of 2 parts, and these are important. If you don't have both of these parts, you don't have a recursive formula. You have to have the initial condition that tells where the sequence starts. So you have to know what t sub 1 is. So t sub 1 equals some value. And a recursive equation, or a recursion formula, that tells how any term in the sequence is related to the preceding term. And that was our t sub n formula. In part 1, you were given explicit definitions for a sequence. To see the contrast between the recursive definition and the explicit definition, consider the arithmetic sequence 23, 20, 17, 14. My recursive definition is my initial condition is 23, meaning I'm starting at 23, and then I'm going to take that term and subtract 3. So the recursion equation says that each term is 3 less than the preceding term. And the explicit definition is t sub n equals 26 minus 3n. So t sub n is given explicitly in terms of n. So that means I'm going to use my t sub n equals t sub 1 plus n minus 1 times d formula. D in this case, because I am subtracting 3 every time, would be negative 3. And then I just distribute my negative 3. So I get negative 3n plus 3. Combine my terms, I get 26 plus minus 3n. This will allow me to find any term at any given time. I do not need to know the one preceding it to find it. Recursive one means I have to use the preceding term. Sometimes it's possible to find an explicit definition for a sequence when you are given its recursive definition. And really, that's all there is about the recursion formulas. These are the examples we will work on in class. Today, I want you to put a star next to the exercises to be handed in for this section. So where that's highlighted, I want you to put a star right in front of exercises to be handed in.